This is Algebra Lesson 6.2, Systems Using Graphs. The first example says, solve the system of equations by graphing. It's giving me two equations in slope-intercept form. If we recall, we did that last lesson, and we've done that in the past too. Slope-intercept form, sometimes we say y equals mx plus b. Sometimes we say y equals a plus bx, but remember the rate of change always gets the x, and the y-intercept or starting value always is alone. So let's go with m and b. So for the first equation, my m is 3/2 because that's by the x, and my b is -2. So that means on my y-axis, I'm going to put a point at -2. That's where we start. And then my slope is my rise over run. So from the -2, I'm going to rise 1, 2, 3, and I'm going to run 1, 2, and this is where my dot should go. So I just did those other ones to help me count, but I want to go up 3 over 2, and that is my point. We're going to repeat that a few times, up 1, 2, 3, over 2. And this is where my dot should go. And I can't really go up 3 without running off the graph, so I'm going to stop there. But I'm going to go backwards, because I could go down 3 over 2, down 3 over 2, down 3 over 2, and put another point over here. I want to go as far as I can to cover the grid that I'm provided, and then we'll use a straight line covering the graph. So that is -2 plus 3/2 x graphed. The second equation, my m and my b, my m is -1. When there is no number, there's always that invisible 1. And slopes, when we're graphing them, fractions make it a lot easier because that always gives us our how much to rise and our how much to run. So I had that invisible 1 in front of the x. Because it's a whole number, I also have that invisible 1 in the denominator. My starting value, my y-intercept, is 3. That's right here, the quantity in my equation with no variable. So we're going to start on my y-axis at 3. And then my slope is telling me to rise -1, run 1. So rise -1 means go down 1. Run is positive, so +1. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, all the way to the edge of the graph. And I'm going to work my way backwards to continue that pattern so I can see where my whole line should go. We can connect those points right there. And the objective when graphing lines to solve is to see where the lines cross. So I can see an intersection of these lines right here. So that is going to be how I would report my x and y answers. From the origin, that is 2 units to the right, so my x is 2, and it is 1 unit up, so my y is 1. Next one, I tried to do a little bit trickier equations. I have y equals 3, and I have y equals 2x. So these are both in mx plus b form, but the problem is I don't have an x in the first one, and I don't have a b in the second one. So the first one, my m and my b, I have the 3 for the b because there's no x, so I can't find the m. But if there is no x, it's because there is no x, so 0 x's. I'm still going to put it over my invisible 1 because I like this to be in fraction form for graphing. My second equation, my m and my b, I have my x, so I know my m is 2. I'm going to go over invisible 1 to fraction that. My b is not given because there is no b, and 0 is another word for none. So we have my m and my b of my first, my m and my b of my second. Let's get graphing. First equation, b is 3, so on the y-axis, we go to 3. My slope is rise 0, run 1. So if I go up 0 but go over 1, I effectively have a horizontal line. My second one, the b is 0, which means I'm going to start my first dot right at the origin. My slope is 2, so rise 2, run 1, up 2, over 1, up 2, over 1, 2, 1. And I'm going to go backwards the same way. so that I can fill in my whole graph. To report my answer, I want to say where these cross. Now, unfortunately, these aren't crossing right at a whole number, but that happens. So we're going to estimate that as best we can. I can tell for sure the y value is 3. The x value is between 1 and 2. So let's just say 1.6 or 1.7. Just an estimate. I don't really care for you to get the exact answer when graphing. If an exact answer is what we're looking for, then we would be using one of the other methods that we'd be discussing in this packet. So just an estimate based on the graph when you're using graphing as a method. And part B, we're going to revisit the equation example, the example that we had last lesson. We have the equations already given to us. We wrote those in a previous example, but we're going to graph them instead of use tables this time. So Ann, my M and my B, M was 1 and B was 0.5. Bev, my M and my B, M was 1/2 and B was 2. And again, I can over 1 that guy. So to do Ann, we're going to start at 1/2. And then we're going to rise 1 and run 1. And we're going to follow that pattern and graph right there. For Bev, we're going to start at a +2. And we're going to rise 1, run 2. So rise 1, run 2. Rise 1, run 2. Rise 1, and that guy's off the graph. So if we connect these right here, the lines should cross right here. I think I just didn't draw very straight lines. But that was 3 seconds for the x. And 3.5 meters for the y. I think if your lines aren't very straight, that might happen to you, so it's a smart idea to use a ruler. Obviously, I'm drawn on a big giant board. I can't use a handy-dandy ruler, but keep that in mind. And I think that's it for the examples. Good luck on the exercises, and let me know if you have any questions.